Hi friends, welcome to Unacademy. Myself Bhavani. Students, as you all know, Unacademy offers plus courses for Karnataka CET students. So students who are interested in joining the plus courses, kindly make use of this code and get the discount BHAVANILIVE. This is a code which will give you the discount. We have different plans, students. 12-month plan at the rate of 12,375. We have 6-month plan at the rate of 10,125. So whichever plan is applicable for you, appropriate, you can join any one of these batches. There are different batches available. One is we have a comprehensive batch where 8 month within 8 months the syllabus will be completed. You have a Kannada batch where the chapters will be done in Kannada. So students who are comfortable with Kannada, you can go and join this batch also. You also have a champions batch, and students in case if you want to enroll your name for any of these combination, it might be PCM, PCMB or PCB, you can join this batch. It has started from 15th of October. Make use of the code BHAVANILIVE every time whenever you enroll your name so that you get the discount. And also student, whenever you subscribe the Unacademy plus courses, you will get all class 11 and class 12 topics that will be done in detail. All the tips and tricks will be shared during these classes. You will be given a daily practice paper, full-length mock tests with analysis and quizzes for self-analysis. And students, for single subscription, you have unlimited access. Therefore, kindly see to it that you are informing about the plus courses with your friends, relative, neighbors, brothers, your own classmates, and see to it that large number of students are getting benefit from these classes. Not only that, kindly watch my YouTube session also. In case if you haven't watched, kindly watch them. Whenever you like the class, do not forget to press the like button and also press the bell icon, student, to get further notification. Check the description box so that you get enough links to join different classes. And students, you can also watch my special classes which is under Unacademy. Those are free classes, so you can be a part of it also. And there are free practice tests are available, so you can write as many as practice tests. You can enroll your name and you can see to it that you are attempting these tests only after learning the particular chapter. Okay, all right. So I think students, we will start with today's class. And do not forget, students, to subscribe the YouTube channel. That is very essential. And also see to it that as many as classes you're watching so that you can prepare well for your competitive level exam. So we will go with the coordination compound. Let us continue with some more questions. See, once you learn a topic, first of all, students, when you learn a particular topic, you have to learn that topic in detail. The NCERT textbook, the competitive level exam, any of the reference book need to be, read thoroughly, understood thoroughly. Once you finish studying for a particular topic, then you should go ahead with the question. Do not straight away jump to the question, student. Okay, so you have to try your level best to solve the problem. You should get the answer, not the you are immediately seeing the answer and then trying the question. Never see the answer and then try for the question. Always you need to work and get the answer, then maybe for clarification you can see the answer. Okay, so we will begin with question number 1. And also student, when you I take a large number of questions so that you feel like you have touched all the areas coming under that chapter. That's the reason why, whenever a particular topic is taken, I deal with a big number of questions. Okay, so we will go for today's question. Question number 12. The spin-only magnetic moment of Ni2 plus in aqueous solution would be. Now I can see here there's a comment saying that write the formulas, isn't it? So see, this chapter, there are very few formulas. Hardly you have one magnetic moment formula, you have CFSC, and you have under the formation constant. Okay, so here there are not much formulas. Yes, of course, if there is a particular chapter which has a lot of formulas, yes, I will see to it that the formulas are discussed before the problems. Okay, so we will start with the question number 12. The spin-only magnetic moment of Ni2 plus in aqueous solution would be. Students, you know how to calculate the spin-only magnetic moment. You know the formula. Mu is equal to square root of n plus 2. Square root of n plus 2. And you know where n is number of unpaired electron. Number of unpaired electron. So atomic number is given Ni2 plus 28, that means it is 3d8 4s2. This is nickel. When I say Ni2 plus, remove the last 2 electron, so it is 3d8. You know that d orbital has 5 orientation. Fill the electron now. There are 8, so you have 1, 2, 3, 4, 5, 6, 7, 8. So number of unpaired electrons are only 2. Therefore, mu is equal to square root of 2 plus 2. That will be square root of 8 Bohr magneton. So students, the spin-only magnetic moment of Ni2 plus is square root of 8 Bohr magneton. Option A will be the right answer. Okay, I hope it is clear. We'll go to question number 13. Students, you can give the answer in the comment box. Read the question and try to give the answer in the comment box. Impossible orbital among the following is. Now, which is impossible orbital? Whenever 4d is given, it means that the first is, 4 is n value. So, n is equal to 4. When n is equal to 4, you know that L can be 0, 1, 2, 3. So, you have 4s, you have 4p, you have 4d, and you also have 4f. So 4d subshell 4d orbital is possible. Therefore, this is a possible orbital. We'll go for the next one, 2s. N is equal to 2. That means L can have values 0 and 1. So the possible orbitals are 2s and 2p. Given is 2s, which is possible. We'll go for third one, that is 3f, student. So if you can see 3f, okay. Students, kindly give the answer. Okay, I can see one of you have given the answer, isn't it? All right. N is equal to 3. L is equal to 0, 1, 2, 0, 1, 2. 3 values. So you have 3s, you have 3p, you have 3d. That means there are no 3f orbital. So answer is option C. All these are asked questions, student, in the previous exams. So kindly make a note that these are the questions which has been asked. So it's very clear by the question you can make out the areas from the, from where the questions are asked and how exactly the questions can be framed. Now go to the next one. Very interesting question and a simple question. Which of the following is a negatively charged bidentate ligand? Option A is acetato-ligand. Option B is dimethyl glyoxymato-ligand. Option C is cyano-ligand. Option D is ethylene diamine ligand. So students, can you tell me what is the right answer? Okay. See, there are various ways in which we can actually, you can go for the answer. One is negatively charged ligand is asked. So among the four, only first three are negatively charged ligand because negatively charged ligand names generally ends with O. So option D is not possible. So acetato ligand is CH3COO minus, which is a unidentate or a monodentate ligand. When I say dimethyl glyoxymato, this is dimethyl glyoxymato ligand, 2 nitrogen bidentate, and you can see there is a negative charge. So answer should be option C. Cyano is Cn minus, which is a unidentate ligand. Ethylene diamine. Now ethylene diamine is also bidentate ligand. Even En has 2 donor atoms. As you can see, it contains two donor atoms. But then there is no charge on this ligand. This is a neutral bidentate ligand. And the question is asked anionic or negatively charged. Therefore, answer should be option B. Okay. Go to the next one. The secondary valency of platinum in tetraamine dichloroplatinum 4 chloride. So students, you have to find out the secondary valency of platinum in tetramine dichloroplatinum 4 chloride. So what do you think the answer will be? Look at the options. A, you have 6, B, you have 4, C, you have 2, and D, you have 3. So what do you think will be the right answer? Secondary valency of platinum in tetramine dichloroplatinum 4 chloride. Okay. Now, how do we write the structure of this complex, whatever is given? You can see platinum tetraamine, that means NH3,4, isn't it? NH3,4, and it is dichloro, that means Cl2, okay, chloride. Now, how do you write the number of chloride? It's given here as +4. Ammonia is 0. Cl2 is -2. That means charge here is +2. So, this should be -2. That means Cl2. Anyway, the question is about secondary valency. What is secondary valency? In Werner's theory, you have studied primary valency is oxidation state. Usually when we refer to primary valency, we consider as oxidation state of the metal. And when we say secondary valency, it is nothing but coordination number. That is total number of coordinate bonds. So whenever secondary valency is asked, you have to find out the total number of coordinate bonds. In this complex, there are 6 ligands and all of them are monodentate. Whenever you have a monodentate ligand, the number itself is a coordination number. And what is the number? You have 4 plus 2, 6 ligand. So 6 is the coordination number, or 6 is secondary valency. Therefore, answer should be option A. Students, the secondary valency of platinum is 6. Option A is the answer. Okay, I hope students, you have given different answers, so I hope it has been clear now. You have understood now. Okay, we'll go to the next one. Which one of the following has a magnetic moment of 1.75 Bohr magneton? Students, you have to select the ion which has 1.75 Bohr magneton. Okay, so kindly see the option: Fe3 plus, titanium 3 plus, vanadium 3 plus and chromium 3 plus. You have to find out among these ions which ion shows or give a magnetic moment of 1.75 Bohr magneton. Students, there are different ways in which you can solve this problem. Now, you all know that whenever we refer to magnetic moment, you have the formula mu is equal to square root of n plus 2. Right? Square root of n plus 2. If I take n as 1, then I will get square root of 3. If I take the unpaired electron as 2, student, I will get it as square root of 8. You know, square root of 9 is 3. So when I say square root of 8, my answer will be somewhere in 2 point. It cannot be 1.75. In order to get 1.75, the number of unpaired electrons should be 1. Okay, so I need not to calculate the entire solution. We need to just find out among the 4 options which option has 1 unpaired electron. Among the option which is having 1 unpaired electron. It's easy to find out, student. Actually, you can do it in your mind. I'm just showing it how to do it. You know, iron is 3d6 4s2. Now, configuration, you should be knowing it. They might give you the atomic number, but then configuration, better you know it so that you can solve the question quickly. 3d6 4s2, remove 3 electron, that means you have 3d5. So student, I need not even to draw the boxes because we know all the electrons are unpaired. That means there are 5 unpaired electrons. So this is not the answer. Go for the next one. Titanium 3 plus. When I say titanium 3 plus, after scandium it is titanium. Therefore 3d2 4s2. Remove 2 from here, 1 from here, that means 3d1, student. You are getting it, 3d1. So how many unpaired electron? There is only 1 unpaired electron. Therefore, answer is option B. But then we will check whether sometimes what happens is more than one answer by mistake, if at all it is given. So I can just check it. Vanadium 3 plus. So scandium, titanium, vanadium. Vanadium means 3d3 4s2. I am removing 3 electron, so I am left with 3d2. So number of unpaired electron is 2. So I am going to get this answer, 2 point something. Chromium 3 plus. Chromium is 3d5 4s1. 1 from here, 2 from here, that means I am getting 3d3, student. So number of unpaired electron is 3. So the only possible answer is option B, that is titanium 3+. I hope students you have understood. Okay, this since I have given you lot of lot of explanation for this question, I am expecting directly the answer. The spin only magnetic moment of Ni2 plus. Ni2 plus, student, you know the configuration. It is 3d8 4s2. You have to remove these 2 electrons. You know the d orbital, there are 5. So 1, 2, 3, 4, 5, 6, 7 and 8. So number of unpaired electrons are 2. That means mu is equal to square root of 2, 2 plus 2, square root of 8, square root of 9 is 3, smaller than 9, that means somewhere in 2.84 can be the answer, because this is very close to 9. Okay, so answer will be option B. Okay. Now go to the next one. Kindly solve this question. Which among the following is a paramagnetic complex? You have to find out among the 4 options given, which is that complex which will be paramagnetic in nature. Atomic number of molybdenum is given, platinum is given. There are 4 complex you have. MoCO6, okay, you have CONS3 3 plus, platinum EnCl2, COBr4 2 minus. Students, you can kindly think over the question and you can see among the following the one complex which behaves like paramagnetic or which shows paramagnetism. Now which one is the right one? See, when such questions are given, you have 4 options, student. Now how do we work and how do we minimize the timing? See, it is not that every time we need to work on all the option and try. Whenever we feel that we can work with some option which may be likely to be a right answer, then go ahead with that option. For example, here the question is about paramagnetic complex. You know, paramagnetism means presence of unpaired electron. Paramagnetic complex means there should be presence of unpaired electron. Very important point. And we have studied in coordination compound chapter, whenever the complex has a strong ligand, then the unpaired electron pair. That is one of the point. And we also studied that halogens or haloligands or halidoligands are usually they are considered as the weak ligand. So instead of trying all these, I can go with the complex which has the weak ligand, okay, where the pairing of electron does not take place, because whenever there is a strong ligand, the unpaired electron might pair up. If I am not going to get the answer here, then let me try with rest of the option. So let us take option D. I have told you the reason why I have taken. I can see Br minus is a ligand, and bromido ligands, or in other words haloligands, are weak ligands. So we will take this complex COBr4 2 minus. Now if you can see here, cobalt is in 2 plus state. Students, all these things you need to do mind work. You cannot, you need not spend time. Only in case if you do not know, then you can, X, Br carries -1, -4, sum is equal to -2. That means X is equal to +2. Otherwise, directly you can solve it. CO2 plus. You know the configuration of cobalt, it is 3d7 4s2. So 2 electrons are removed. So the configuration is 3d7. D has 5 orientation, you are aware of it. Each orbital must contain 1 electron. So 1, 2, 3, 4, 5, and you have 6 and you have 7. There are unpaired electron, and bromido is a weak ligand, so the unpaired electron will not pair. So naturally you will have a paramagnetic complex. So answer is option D. Students, I have told you, you have to first target on that option which you feel maybe this is the answer. Okay, all right, that will save your time sometimes. We'll go for 19th question, simple one, direct question. Okay, the number of unidentate ligand in the complex is called. The number of unidentate ligand in the complex ion is called. Is it effective atomic number? Is it a coordination number? Is it primary valency, or is it oxidation number? Students, the number of unidentate ligand. Let me take any one complex, maybe K4, FeCN6. In this you have unidentate ligand, and as you can see the number of unidentate ligand is 6. So 6 is a coordination number. You know that coordination number of ion is 6 here. I can take any other complex, maybe CuNH3,4, SO4. This is also unidentate ligand, and this number is nothing but coordination number 4. So number of unidentate ligand in a complex is nothing but coordination number. Effective atomic number means number of electrons in the metal and the number of electrons given by the ligand. If you add them, then you will get effective atomic number. Primary valency is the charge on the metal. For example, K carries +4, iron is X, Cn carries -1. So charge on iron is +2. That means primary valency is +2. Primary valency itself is coordination number. Therefore, the only possible answer is option B, coordination number. Okay. Go to the next one, student. Molar conductance of a complex cobalt is 0. Then its structure would be. So students, this is a simple question which can be answered. Complexes are given where it is said that the molar conductance is 0. So what would be the structure? Is it option A, B? You can see there are option C and option D. What do you think is the right answer, student? When this complex is dissolved, it will give 3 chloride ions. This will give 3 chloride ions. This will give 1 chloride ion. So whatever ions which are present outside the coordination sphere, they will give the ions, isn't it? And they are involved in conductance. You're going to get one complex ion and rest of them are Ishri, this time I'm not given actually. Okay, that's why that is a problem. So you can request, then if I get, surely I will be taking the classes. All right. So students, as you can see, the last one, the last complex, it is not involved in ionization, because only if you have ion outside, then it will be involved in ionization. So this cannot be conducting. So the conductance is 0. Answer will be option D, student. Option D will be the right answer. Okay, go to the next one. The complex platinum Cl2En2 2+ ion shows structural isomerism, optical isomerism, geometrical and optical isomerism, and geometrical isomerism only. If you have the answer, kindly put it in the comment box. Some of you are answering right, students. Very good. So keep on attempting, keep on trying. Sometimes you might not be knowing the right answer, but then you do not stop trying for the right answer. Look at this complex now. This complex can be written as platinum Cl2 En2 2+. You can see identical groups are on the same side, cis. Platinum identical groups are on the opposite side. So you can see here which one, Ashri, you are asking YouTube classes. That is given, Ashri, Ishri, I'm sorry, that is given to me. So how they give, we take up the classes. Okay, so identical groups are on the opposite side, therefore this is cis and this is trans. So of course it shows geometrical isomerism, cis and trans. Now the question is, do they show optical isomerism? If you take a cis isomerism, you take the cis isomerism, okay, like this. And if you keep a mirror, you can see the mirror image is like this, right? Only the cis it will be like this. Okay, so students, what happens is, here you can see here the cis isomer can be optically active. You look here now, you can see these are non-superimposable mirror images. You cannot superimpose this one. Okay, this is not there. Non-superimposable mirror images. That means they are exhibiting optical isomerism. One is dextro and the other one is levo. That means this complex can show both geometrical and optical isomerism. So the answer is option C. So students, I have already crossed my time. See students, according to the time schedule given, I take class. So whenever it is given, I take up the class. So my next class will be on 22nd exactly at 2 o'clock. Till then, students, keep studying and see to it that you are getting large number of students in these for these classes, and trying to help others also. So kindly share the videos. In case if you have liked the class, do not forget to press the like button, and we will see you on 22nd exactly at 2 o'clock. Okay, till then, bye bye and take care, students.